Reality and imagination are two intertwined concepts that shape our perception and understanding of the world. Reality represents the tangible, concrete aspects of existence, the physical objects, events, and experiences that we encounter. It is the realm in which we navigate, interact, and make sense of our surroundings. On the other hand, imagination ventures into the realm of possibilities, untethered by the constraints of reality. It allows us to explore and create alternative scenarios, ideas, and visions beyond what is immediately observable. While reality grounds us in the present, imagination enables us to transcend boundaries, dream big, and manifest new realities. Today, our discussion revolves around a complex and elusive concept that encompasses various aspects of astrophysics, making it particularly challenging to grasp. It intertwines elements such as black holes, the expansion of the universe, and quantum physics, while delving into the nature of reality itself. We aim to explore a study that potentially shed light on why physical objects like you, me, exist and possess distinct properties, contrasting the uncertain and undefined nature of quantum realm. So, stick to the end. You'd really not want to skip a second. The Copenhagen Interpretation of quantum physics proposes that everything can be described as a range of possibilities until observation or interaction forces it to manifest a specific state, akin to how an object transitions from an intermediate state to a definite one, or in simple words, things don't exist until an observer is observing or interacting with it. The classic illustration of this concept is exemplified by Schrodinger's cat, which exists in a superposition of being both alive and dead until the box is opened, collapsing the quantum state. Now, the question is, what causes the coherence of everything around us? The scientists in question seek to address what triggers the collapse of particles and the coherence of the surrounding environment by applying certain Einstein principles. This somewhat hypothetical paper discovered something that could be potentially groundbreaking, if they're of course correct. For example, we know that quantum objects lose their quantum properties as soon as there is some kind of observation or interaction. But let's take this idea a little bit further and try to imagine that the observer is really far away from the object. Or let's just say this observer maybe is in another galaxy, really far away. Well, according to quantum physics and according to pretty much all the math behind it, this particular particle is still going to collapse because in this case, the particle is entangled with the observer, which is going to create what's known as the coherence, and that's despite the fact that this observer could be thousands of light years away. It is crucial to note that this does not imply faster than light communication, but rather suggests that quantum decoherence has already taken place once information from one object interacts with another, aligning the modern quantum mechanical principles. To further explore this idea, let's consider an analogy involving a distant observer and a Toyota car. According to quantum physics, when the observer gazes upon Toyota from a different galaxy, the Toyota car assumes a specific property, losing its quantum nature and becoming, for instance, a BMW. Taking this thought experiment a little bit further, what if the observer crossed the event horizon of a black hole? Despite the light from the Toyota entering the black hole and crossing the event horizon, as per Einstein's theories, there is no way for information, including the entanglement, to escape. Now, coming to the most interesting section of this video, this predicament presents a paradox, implying that either quantum physics is incorrect, which is highly improbable, or a solution lies within general theory of relativity to explain this principle. The scientists propose a potential resolution in this paper, suggesting that the event horizon itself acts as an observer, causing the collapse of quantum states. Let me say that again. In one of the previous papers, the scientists behind this idea managed to mathematically solve this by assuming that the event horizon of the black hole, or the point of no return from where no light can escape, actually starts acting like an observer itself that causes the coherence and causes things to collapse. Although lacking physical evidence, this notion aligns logically and mathematically. Consequently, black holes throughout the universe may serve as colossal observing entities, potentially shaping the reality we experience. Also, they actually went a little bit further in their recent study, realizing that this type of horizons where nothing can actually escape is where things crossing the event horizon starts violating certain quantum principles and may also start to exist somewhere else in the universe. Building upon this intriguing proposition, the scientists extend their recent study to consider similar horizons, where quantum principles break down. Those particles may transpose elsewhere in the universe, hypothetically at the edge of the observable universe. Due to its expansion lies another event horizon called the Rindler horizon or the Killing horizon, named after Wilhelm Killing. This horizon exhibits comparable behavior, causing quantum states to decay. Consequently, the edge of the universe starts to act like an observer, influencing the properties and formation of physical objects, thus shaping our perceived reality. Even though this sort of resembles an eyeball and sort of acts like observing everything in the middle and causing quantum particles to assume shape, assume properties, and to create objects or to create the reality we know. This does sound somewhat metaphysical and erroneously can start bringing in the basic idea of religion. But does that mean we are basically defining God? Well, according to scientists, it's quite the opposite. It does not mean that the universe is conscious or that it represents some kind of godly being. Instead, it seems to provide an exact objective way that causes quantum states to create physical objects, relying on principles from Einstein and from quantum physics, and more importantly, potentially providing a link to both. While the proposed explanation holds the potential to clarify the working of our universe, it remains highly theoretical and speculative. Our current understanding of black holes, the objects that may hold the key to this explanation, is limited, and they might possess properties that differ from our current knowledge. This presence of infinity within black holes, known as the singularity, is a mathematical construct that challenges our understanding of the physical world where infinity does not exist. Nevertheless, the concept suggesting that the coherence of the entire universe arises from radiation such as photons or hypothetical gravitons emanating from the periphery of black holes and the edge of the universe is undeniably captivating. It implies that if the universe were not expanding rapidly, or if black holes did not exist, our reality, as we know, would not exist either. Such implications are awe-inspiring. But it's unlikely that we will gain much more insight from these ideas without further advancement in our understanding of black holes and the events occurring at their event horizons. The fate of objects that venture into black holes remain a mystery that cannot be answered in near future. However, as our knowledge progresses, I will gladly revisit this topic to explore any new development. Thank you for your attention. Also, another interesting idea. Did you know Betelgeuse has suddenly become brighter and the seventh brightest star in the sky? Is this the end of this colossal star?